So before moving into the details of the call flow and signal and registration and other stuff, I would like to take you through a very high level of the call VoLTE call procedures in general. So actually, you can say it's being divided into four steps. The first step, if the user is not being registered at all as a network, so you need to initiate a registration or attach message to get the default peer, which is QCI 609. This is the first step. Then after he got the XI 609, the user himself will start initiating a BDN connectivity request to the MME, asking him to, I would like to establish my IMS ABN and so on. So, and to acquire for example, the addresses or the IP address of the IMS network, which is in general the proxy, specifically about the Proxy-CSCF, which is the first point of contact. Then after that, the MME will forward this request to the other entities, and it will establish this default peer XI5, and it will assign or inform the user about the IMS addresses for this for the user. It will transfer all this information within this kind of step. Then once the user got the XI5 established, or yes, established in the network, he now will start initiating the IMS registration, because all of this is not all of that he's still not yet registered to the IMS network. But once he have a XI5 being established, he will now being able to send all the SIP messages towards the IMS network. So this is the third step. He will be initiating the IMS registration, and we'll covering all these in details with signal context and the second part of this video. Then after he make the registration now, and all the SIP signaling being done, then he will initiate, the users will initiate the VoIP session, and the network in general, or network will start initiating and assigning the dedicated bearer or configuring the dedicated bearer for the UE, between the UE and the network in general. And here where the media flow will be established between both originating and terminating, and then now the RTB media will start being generated, and the speech traffic in general. Then the last part, it's about releasing the call. Okay, this is actually here we're going to explain the end-to-end call flow for the attach in the 4G. And actually, the main idea that the users, whenever is going to make attach, the main idea here and the most important information which you need to know about, which related directly to the VoLTE, it's related to the VoLTE preferences and so on, and IMS preferences, which is usually included in the attach message. But it's also important to understand the overall call flow. So let's see what we have. Initially, when the user does attach, he will send the attach request as shown here. It will go through the inode B. As you can see, this dotted line. This means it's transparent for the inode B, because this is NAS message. So it will go through to the MME. And usually this message will be piggyback in the S1AB initial UE message. So you will find a message called initial UE message sending from the inode B to the MME, and this one including the attach request which is being sent by the user, because this is using its NAS message. And this attach request actually including many important information. We'll go through the most important, which are related to the VoLTE. For example, the UE identity and capabilities, and also the usage settings, which are related to the voice domain in general. And this is will be our focus point in the next slide, which contain the details about that. Once the attach request is being sent here from the UE to the MME, the MME, after he received the attach request, he need to acquire some information or to collect some information from the HSS about the user identity, for example, his location and so on. So what will happen? The MME will send something called ULA, which stands for update location request. This is including actually what kind of RAT, for example, is coming in 4G, and also the MZ or the GUTI information for this particular user, which is being reported and attached. So the MME is requesting to HSS to share this kind of subscription data for this particular user, and also all the related features supported for this user, especially for the HSS features. So the HSS will be replying with the subscription data and the supported feature. So as you can see in the point number 2 here, the once the MME triggered this diameter update location, which is the HSS will now return the MME. It will send the quality of service for this particular users, which is being returned in the HSS, and also the geographic position, which was already shared. And also at the end, it will inform the MME that this user is being allowed to attach to the network or not. There is no restriction, for example, in this particular user. And actually, once and during this message, now the HS can store updated information about the user location once in this particular ULA. And this is ULR. This is the response for the update location response. So this is very important as well. Actually, in between, there is some authentication security messages should be there as well to make sure the user is authorized to access to the network and also the authentication process. But I just excluded for simplicity point of view. So once this one is being received now, the MME need to send to the serving gateway something called create session request, as you can see here, create session request, and this actually message should go to the BGW, and this is requiring that the user would like the MME would like to open a tunnel with the serving gateway and BGW as well. But since there is no direct communication between MME and BGW, it will go through the SGW. So if you look into that part, the create session request, including a lot of information. One of them is the MZULGUTI, for example, the MME ID for the control plane. Actually, the MME is telling them that my GTP or the tunnel endpoint control plane is it's informing them about its GTP tunnel endpoint. And the tunnel endpoint or GTP in general, it's like the radio bearer between the UE and the InnoD, which used to carry the traffic, for example, or the signaling and so on. So this is like informing them it would like to open now to have a tunnel between the serving gateway and MME and also the packet gateway. And also it's telling the serving gateway about BGW address IP to make sure that the serving gateway will forward this kind of message, which is create session request, to the appropriate or the correct BGW. And also about the BDN type, which is being sent in the attached message. BDN type, actually, it's just the user was telling them that I'm supporting, for example, IP version 4 or IP version 6. In case if user supporting both of them and the network supporting IP version 6, so the user will be selecting IP version 6. This is in case of that. And the IBN type, for example, this is initial, it will be, for example, for data or web or whatever, and RAT and quality of service. So the same message will be forwarded from the serving gateway to the BGW with the exact same content. So the next, actually after that, the BGW will be responding with create session response as showing here for this create, and now it will be do the same information. Now do you want to have end-to-end to open end-to-end channel in terms of GTP or the tunnel endpoint? So it will tell them my IP is XYZ and my tunnel endpoint for the user plane and control plane, UB is user plane and CB is control plane, is this is my tunnel endpoint. So now this connection or the tunnel end-to-end tunnel endpoint or GTP is being now created between the serving gateway and BGW, and it will tell them what kind of BDN type is being selected, for example IP version 4 or IP version 6, and it will give them information about the quality of service and the BS peer identity in general, for example which KCI is going to be used, what kind of information for the quality of service and so on. So the serving gateway will return the same information to the MME, but it will add some information on top of that. For example, here it will add its own IP addresses for the serving gateway to the MME to make sure that S1 connection is being created, and also it will add the TE tunnel endpoint for the packet gateway as being sent here for user plane control plane, and the remaining information was just being mentioned. Once this message is being received, the MME need to communicate back to the inode B through asking the inode B to start creating the context for this particular user. So now it will be sending this initial context setup request, which is actually the equivalent to attach accept message and active default ABS period request. So in this message, actually, it will include almost the same information which being sent here, except for for sure the TED or this kind of information just between these three entities. But the most important, it will have the BS period, quality of service, and also the MBR messages. And this is in the area interface, you'll find this one called attach accept and also activate default EBS period request. By the way, in the attach request, this is also related to the BDN connection request message. So, and this is both of them is being piggyback in the initial UE message. So once this message is being sent to the UE, now here this will be the bearer will start like creating the bearer for this default bearer between the UE and the inode B. Once it's being successful being done between both of them, the inode B will responding back for this initial context stop request with initial context stop response, which is now it needs to tell them what kind of my information, for example what kind of my inode BT ID as well, just to make to open a channel now between the inode B and serving gateway as S1U, right, user plane, between the input B and the serving gateway. So it needs to send, it's also a GTP tunnel endpoint. And it will then tell that your downlink path now can be to open the downlink path from serving gateway to the input B. It need to tell them about its own IP and tunnel endpoint. So this is the main point here. After this message, actually, the UE will now send directly to the MME through the NAS message that, okay, attach is being completed, and now the default peer is being activated, and attach being completed now successfully. So the last point now, which is very, very important, as mentioned here, after all that, the MME need to inform the serving gateway about this kind of information, which is the init B tunnel endpoint and the IP, which actually being completed after the setup. And the main idea to make sure that now the uplink and downlink path is being created between especially the init B and the serving gateway for the user plane path. So it will, last point here, you can see it will send modified bearer request, which is sending all the information about the BS, which is being already acknowledgement in 8 and 9, and the information about the init B, which is the tunnel endpoint, and the IP of the UE, the init B. So now this process is being completed for the registration. Now, next slide, we'll go through the details about the directly related information to the VoLTE call in general. So here I would like to take you for very, very important information. It's related to directives of VoLTE. For example, if you would like to confirm or to check during the troubleshooting or in general what kind of capabilities we have in the network, even from the U side or from the network side. So we need to check the attach request message. This can be checked from drive test and example, or initial UE message from the S1 AB traces in case if you have Wireshark or you have traces being open for both of them. It will both of them almost contain the same information. But the most important information related to the VoLTE, it actually need to look into two parts. As you can see in the right side here, you have something called voice domain preferences and UE usage settings. You'll find two pieces of information on that part. The first one called UE usage settings, whether it's voice centric, and this is usually, and this is having two types. It's even voice centric or data centric. For example, the user it's himself, even the device or the SIM card is not supporting voice at all. So he will be sending data centric. So in this case, he is not able to perform a call. And the second part, for example, the voice domain preferences for EUTRAN. This one actually having 4 domain or 4 types. I will explain the 3GPP definition shortly about that part. But for example, it can be CS only, which means it will be CS fallback. And it can be IMS, as you can see here, IMS PS voice preferred, and CS voice as a secondary. So the preferred one is IMS, then followed by the CS. I will explain what it means by this through some flow now, but this is just keep in your mind that there is 4 types of the voice domain, but the one which you use usually is IMS being preferred and CS as a secondary. Then this one is just the UE is telling the network the core network about its own capability. So it's telling them, yes, I'm supporting this service C2G RAN and UTRAN capability is being supported. So it's telling them their capability. Once the MME receive this message, it's need to respond back about the network capability itself as well. So for example, in the second message you can see down here, attach accept message, I'm highlighting the most important information to the VoLTE in general. You can see it's sending something called IMS, voice over BS, is being supported. So now the network, the core network is confirming its own capability that I'm supporting IMS. So in case, for example, you found that here this information being sent as IMS preferred, but the IMS replied was not supported, this means the IMS or the VoLTE call is not being supported, and you need to check with the core team what kind of actions need to be done from the core side. So now let's explain what it means by this in more details, voice-centric and IMS voice preferred. Okay, as you can see in the two figures in the left here, the first one here in the top left is showing that the voice domain preferences can have 4 types, as I mentioned, this part. It can be even sent as CS only or IMS only or CS preferred and IMS secondary and IMS preferred and CS secondary. And this is the one usually used for the VoLTE network or the IMS. So the first one, CS only, means CS fallback only. And this one means, for example, CS preferred means that the CS or CS network is CS fallback more preferred compared to IMS, and this is the opposite way around. So how this works actually, we have this 2 pieces of information, something called US voice centric, and the second one for that part. So I just quoted one example from the 3GPP. As you can see here, the user initially set his preferences as IMS PS voice with CS voice as secondary. So the IMS is being preferred, and CSL secondary. So what the network will do? Initially, the user will be sending this message. So the user will initiate this combined ABS MZ attach procedures, and if the attach is being accepted as showing here, attach is, and there is no indication from the core network that CS fallback, for example, is preferred, CS fallback is not preferred. So what we'll do, the UE will check this kind of message, which is the network capability, whether it's being supported or not, IMS VoIP over PS. So a UE checks for IMS voice PS session supported or not. If it's supporting, then it will. If it's not supported, it will use CS fallback. But in case if it's being supported as showing here, it will use directly the IMSPS voice, which means a VoLTE call. So it's dependent on this message. So in case if the attach is being failed or not accepted by the network, again the UE will go and check the capability of the network. So if assume that the main network mentioned that it's not being supported for the it's not supporting to have IMSPS. So now this is the second piece of information will come into the figure, which is now the UE will check, the network will check this kind of information, which is for example centric. If the UE checks first his voice centric or data centric. So once the UE check this part, for example, he found that he's voice centric. So as long as the IMS is not being supported, he will reselect back to other RAT, for example, to 3G. But if it's data centric, means he cannot initiate any calls, so we'll stay in RAT and in the same technology, which is for example the 4G, and the call will fail. So this is the overall flow, and you can find all the details about this, the remaining four, if you'd like to go through details through this kind of version 3GP. So now let's move to the next part. So once the UE completed his attach, the first attach. After that, as you can see here in the top left here, the user completed already the attach, which is using the PCI 619. Now, the user need to initiate another attach or another BDN connectivity request, requesting for the IMS ABN, and also he would like to get the Proxy-CSCF IP for the IMS in order to be able now to start the IMS registration. So actually here in the top right here, the right and the further right, this is end-to-end call flow. It's exactly same, almost the same as the registration. For example, initially you will send the BDN connectivity request, requesting the IP address of the proxy in this particular message. I will show this one in the next slide in details. So requesting that I would like to get the Proxy-CSCF IP in order to be able to communicate with the IMS network. Then again, the MME will start following the same process which being explained in the 4G attach message. It will send create session request for the serving gateway, which is including again the tunnel endpoint, and also adding the information about the BDN type, IP, and also requesting which is the most important here, requesting the Proxy-CSCF. And this message will be forwarded to the BGW, including the same information. Then here there will be something called IP CAN between the BGW and BCRF. The IP CAN actually it's abbreviation for IP Connectivity Access Network. And the BGW is just asking the BCRF, okay, now we would like to get the information for the ABN, which is IMS PCI 5. So I need the BCC rules, and the quality of service information about the PCI 5. So the BCRF will be responding with this kind of information. Then after BGW receive the response, it will send create session response to the serving gateway, which including the information about the IMS ABN and the PCI 5 information, and also the information about the IP of the P-CSCF in general. And also it will sending, if you remember, we mentioned that the tunnel endpoint for the GTB. So it will for its own tunnel endpoint in order to create the new tunnel or new GTB to call between the serving gateway and back 5 for that part, because we need a new tunnel endpoint for the QCI 5. The first one was QCI 6 to 9. Then it will follow exactly the same what we have mentioned before until it's being complete. Then actually what I would like to discuss with you in details, it will be about the BDN connectivity request, what kind of information which you have it here, and how the UE is getting the information from the network, as we just mentioned here, and what is the message content. So let's move to the next slide. So now let's see what we have as the content of this message. For example, here, the BDN connectivity request, if you open this message, you'll find in that part, it's showing that the UE is requesting, okay, I would like to get the information. First, my BDN type, I'm supporting IP version 4. And here, this is my access point name, which I would like to get information about it, which is IMS. Then within this message, you will find also that the user himself is sending Proxy-CSCF IP version 4 address request. He's requesting, I would like to get the address of the P-CSCF, which is, if you remember, this was the first point of contact for the IMS, and the user would like to get that part to start doing the third step, which is the registration to the IMS. So here it will be sending the request. Once he receives the response from the unit B or through the steps which we just explained previously, it will say he will receive this activate default ABS period request. And within that part, you'll find that it's having information about the IMS now and the quality of service, and also it will give them the address now. It will tell them, okay, this is the Proxy-CSCF IP version 4 address. You'll find the address here, and this is usually they call it Proxy-CSCF discovery. So now the user he's aware about the IP. He can start communicating with the IMS in general to start doing the registration to the IMS. So after that part, the user will start doing the registration, which will be our next part. We'll discuss about the end-to-end call flow for the registration and also the signaling contents of the registration.